I am Kian, and today I want to teach you how to find the area under the curve of a function on a specific interval. So we have this function y equals x squared plus 2, and we want to find the area under the curve and above the x-axis of this function on the interval from 0 to 1. So if we use the subintervals forming a rectangle under the curve, we all know that the area of a rectangle is just the width times height. So for finding the width of this subinterval, we use a formula and we call it delta x is equal to b minus a over n, where b and a come from the intervals. So it's 1 minus 0, which is 1 over n. So now we have found the width of this rectangle. Now for finding the height, the formula is just parentheses 1 over n, which is the width, times k. So we have k over n, and then because this degree of this function is 2, we have to raise it to the second power and add 2 to it. So this is the height of this subinterval. So now for finding the area, we should multiply these together. So if you multiply 1 over n times k squared over n squared plus 2, the quantity we get is k to the second power plus 2n squared over n cubed. So this is a resultant of multiplying height and the width of the sub-intervals. So the next step is to evaluate the sum of this expression from k equals 1 to n. So first, we should simplify this expression as k squared over n cubed plus 2 over n. Now we all know that we can take the sum of this expression individually. So we can take the sum of k squared over n cubed and then add it to the sum of 2 over n. So I'm going first to take the sum of 2 over n, because 2 over n is not, we want to take the sum respect to k, and 2 over n is another variable. We can take out 2 over n outside of the sum and we're left with 1. So the sum of 1 from k equals 1 to n is just n, and n times 2 over n is just 2. So one part of the answer is 2, and then plus we have k squared over n cubed. Again, because we are working with variable k, we can take out 1 over n cubed and multiply it by the sum of k squared from k equals 1 to n. Now k squared has a principal value of n times n plus 1 times 2n plus 1, and all over 6. Now the next step is to multiply 1 over n cubed by this quantity, where we get n times n plus 1 times 2n plus 1 all over 6n cubed. Now the next step for us is to add this expression, and the last step is to take the limit of this expression as n approaches infinity. So for spaces, I'm going to erase this part of the drawing, the graph. So now if we add these two expressions, the resultant that we will get is, I write it here, 14n squared plus 3n plus 1 all over 6n squared, by taking the common denominator and simplifying. Now, as I told you, the last step is to take the limit, I write it here, as n approaches infinity of 14n squared plus 3n plus 1 all over 6n squared. As in my previous video, the first step we should do is that we should divide the numerator and denominator by the highest degree, which is n squared. And if we divide the numerator and denominator by n squared, it has no impact on the value because we're dividing by 1. So if we do that, in the numerator, we get 14 plus 3 over n, And if we take the limit of 3 over n, we know that 3 over n converges to 0. So we can replace 0 for it. And also for 1, if we divide n squared, we get 1 over n squared, and then it converges to 0 also. So we can write the answer as 14 plus 0 plus 0 over 6n squared divided by n squared is just 6, so the final answer is 7 over 3. Now we have found this answer using the Riemann sum. But if you want to check our answer, if it's true, if we have done the steps correctly, we should do the easier step, which is to take the definite integral from 0 to 1 of x squared plus 2 dx. Now, using the power rule, x squared is just 1/3 of x cubed plus 2x, and if we put 1, we get 1/3 plus 2, which is 7 over 3. So our answer is correct. Thanks for watching. Make sure to subscribe and support my channel, and I will make more content on different math related concepts.